Test, test. Oh, that's decent, I suppose. I had a premonition. I had a premonition that my setup was going to be broken when I logged in today, so I decided to check it a little bit early than the usual time. So, yes, excellent, thank you. So, I'm actually on time today, despite technical difficulties. There we go. I just need this to hold together for a week, and then hopefully everything is fine. I might have to switch to my old laptop to, you know. Well, I think if I switch to my old laptop, I'd be able to use my good microphone, but kind of stupid. I don't know what the problem is. Probably some driver issue. So how is everybody? How was your weekend? Ultra busy. Yeah. I hear that. Actually, it wasn't too bad. Once Saturday morning was over with, it wasn't too bad for me. Finally ending this hell of a midterm November with one last one tomorrow. Oof. What's the subject? Is the subject deceptively easy material but with very, very tricky tests and exams? 304A? Or 3AZ4? Statics. There you go. That'll do. That's close enough. Yeah. My gosh. So, a kind of a hilarious thing happened. It's hilarious in a cosmic sense. It wasn't very hilarious at the time. But a funny thing happened in the 1MD3 class that I'm teaching, because they had a midterm over the weekend. And so with that class, we use what's called Jupyter Notebook, which is a system that includes auto-grading. So we write, we write the question, we write the answer. Actually, usually the answer precedes the question. If you didn't know that about like tests and stuff for programming, it's at least my methodology, and the one that I try to encourage in the people I work with, is question, like, answer first, then write the question, because you fit the question to the answer that you make. But anyway, so we use Jupyter Notebooks, which is like a whole system. And you make like one master notebook, which you generate the student's test from. And the master notebook includes like the instructor's solutions and all of the test cases that will be used to grade the thing. And it's taken myself and the TAs about 2 weeks to put this thing together. Not constant 2 weeks of work, but we've been working on it for 2 weeks. And it's like we get to 9 a.m. and it's like we start getting questions on Piazza. Aren't the solutions included with the question here? And it's like, oh. So it turned out that the software process that we relied on to strip out the solutions from the students' test papers before sending them to the students didn't quite work. Which meant that the test got distributed with its own solutions, which obviously means that the test can't happen. So, because I have such an amazing team in that class, we were able to pull together a second test in about 4 hours, although it took about 16 man-hours to pull that together, distributed amongst the 4 of us that were there. But yeah, so that's so we were very apologetic and gave everybody a generous extension on it. 2 hours versus the usual 24 hours. But yeah, so that was a thing that happened over the weekend for me. It was like, geez, man, But I'm not mad at my TA who did that. Like, he's a good guy. It's just like bad things happen to good people, There's no point crying over spilt milk. What you really just need to do in a situation like that is you need to pull together as a team and come up with the best solution and try to get that out as quickly as possible. So simple, right? Anyway, so 14 people viewing. I don't think we're probably not going to get many more than that. So, let's talk about the stuff we were talking about. So we were talking about Mech Files. So Mech Files are the classical way of controlling the compilation of your programs. Just to roughly recap how far we've gotten. When you're writing a make file, what you're doing is you're designing a set of rules. Let me just pull up the make file that we were working on. So these rules can be, let's see here. Oh, I remember where it was. It was in the slides folder. There we go. So, when you're producing a when you're making a make file, the thing you're doing is you're setting up a bunch of rules that perform the compilation of all of the pieces of the program. Roughly speaking, the way that make files constitute a more efficient method of compilation sort of hinges on the idea that your program will be split into sub-executables, essentially. You can compile these directly to object files. Object files, remember, are the stage between, it's like post-compilation but pre-linking. So you can feed a bunch of object files into the compiler and it'll compile them all into one executable, which is good. But the object files themselves, Sea Shanties is a brilliant name. Thank you, sir! Thank you. If you execute that file, it's also It does what it says on the tin as well. There you go. So the object files can be compiled at a different time than the executable itself, which means that you only have to compile those, only those object code files which will have changed since the last time you were editing things. Only those need to be recompiled, and if your project is large enough, you can change. You can reduce the amount of time it takes to compile something by, minutes to half an hour, right? Why does line 2 have the only have the O flag, but lines 6, 9, and 12 have the C and O flag? Excellent question. So the O flag is the output flag. That specifies the name of the output. So if I want to compile top, right? If I want to compile top as an output file, I have to specify that as the output name. Otherwise, they'll just use the default, which is a.out. The C flag specifies specifically compile this to an object code file, right? So it's like produce a .o file. Without that flag, you would be compiling it to, you would be doing the full compilation process right down to an executable. If you include the C flag, it interrupts the process once you've hit object code, which is, kind of the point. So yeah, so that's sort of how you would make an actual file into a target. But you can also have what are called phony targets. So one very common phony target is clean. So often in the process of compilation, and this is particularly true of LaTeX files, I can show you that, but during compilation, you might consider the object files to be useless if you were, for example, going to ship the product. You don't need to include object files, right? So if you wanted to, you could set up a rule that cleans up all of the files that are generated during the you could set up a file that generates or gets rid of all of the sort of generated garbage. And not that object files are garbage, they're useful until they're used. And they're also useful for determining whether or not the like if you delete all of the object files, you have to completely recompile everything. But, it's useful to have a utility that gets rid of all of the things that you don't want. So, so with the recipes, you can use general Unix commands, right? You can use bash commands in here. You can even make references to bash scripts and run bash scripts from in here, because it's somewhat limited what you can do with this. You can't, for example, use loops. Like you can use loops in bash scripting. You can't do that inside of a Makefile, at least not when I tried. But what you can do is you can put any kind of looping behavior you wanted into a exterior bash script and then call that bash script from inside of the Makefile. So yeah, so the clean, if we save that up, if we then make clean, it deletes all the .o files, which of course means that if you make it, it has to re-add them all. But, so be it. So another one, can you use a goto? Why would you want to use a goto? No, this one, as far as I'm aware, there's no gotos in bash scripting. Pretty sure that's the case. I could be wrong about that. Let's, let's take a look, because I'm I can't make a categorical statement like that without fact-checking myself. Let's see. Go to statement in bash script. Let's see what Stack Overflow has to say. No. Apparently not. There's no goto in there's no goto in bash scripting, and therefore there would certainly be no goto in Make Files. Wouldn't make sense to be able to jump into a different rule, right? But anyway, although the way that this is tagged kind of looks a little bit like a goto, doesn't it? So let me show you something then. The top rule is always the default target. So if you invoke make with no argument specified, it'll always just pick the top rule. But it's often, like, especially in cases where you have more than one executable file, it is very often the case that you'll want to have an all rule. So what you do with an all rule, generally, you don't worry too much about putting in a recipe. All you're doing is having it link up to any of the various other rules, and it'll execute them in order. So you can compile top, and then you can clean. And that's what all will do. So, make all. Why didn't that? Did I mess it up somehow? Weird. Oh, come on. This does work. I have to find it now. Maybe if I add another build rule. Build top. Maybe it's because it's like, this is above. Maybe it can only reference things that are below it. That would make sense, actually. Ah, there we go. Yeah. Okay, so there's a rule I probably knew at some point, but then I forgot. If you want a so it'll parse these in order. So if you're referencing something that doesn't exist, like you can't put this line below the thing it's referencing, essentially. Sort of goes from the bottom to the top. So yeah. And if you'll notice, with this other makefile that I made for my thesis, I have a quick build and a normal build option, where the quick build is just a quick build to see if I've got it like a table correct. But the building also builds in all of the bibliography references and stuff like that. Oh yes. Yep. Anyway, so that's about phony targets. Yeah. So, now that we have our makefile in place, we can start compiling. To compile the default goal, simply type make, yes. Yes, nothing could be more simple. On a default invocation, that is, just calling make with no arguments, make will use the first rule as its compilation target. Therefore, your top file should be at the top. Whether the target is default or specified, make recursively processes the rules for all prerequisites of the target rule. So, essentially, don't make all a prerequisite to all unless you want it to never terminate. If the source file is newer than its corresponding object file, or if the object file doesn't exist, make will produce it. For testing purposes, touch updates the timestamp on a file without modifying the contents. Any object file which needs to be linked to other object files will be regenerated as well, if any of the object files it needs are newer than itself. That's the point of citing things as prerequisites. So, any questions about that before we get into complicating things with variables? Or is this fairly straightforward? Give me a thumbs up if you're still doing okay. I'm still a bit confused about what the point of using make files is. It's so that you don't have to type it out by hand each time. That's the main thing. It's like if I were to compile, you know, particularly if I were to perform this particular compilation, I would have to retype out all of these commands each time, right? Or like even if you're backtracking through your list of given commands, if you've done that like 3, maybe 4 times over the course of working on a project, you should automate it, right? So the it's not just about being able to compose a bunch of like if statements and while loops, right? That's not like programming is a bigger thing than just that. The computer is the tool, right? You are like a carpenter, and the tool and the computer is your hammer and your saw and your all of your carpentry tools baked into one little tiny thin thing with a screen in it. One of the things that you're going to need to know, or let's put it this way. One of the things that's going to separate you from your competition when you're applying for jobs and stuff like that is how well you make use of the tools at your disposal. So, while it is certainly possible to type everything by hand, and it is necessary to type things by hand a few times to understand how they're working, once you understand how they're working, the correct thing for you to do as a programmer is to try to make it so that the computer does as much as it can by itself without needing your intervention. Like, you have to make the computer your bitch. That's how it works. What kind of questions require you to have multi-line compiling? Questions. Well, I mean, you should be thinking programs, not questions, right? If you take a look at any sufficiently large project on GitHub, you'll be seeing this type of thing going on, right? when you're answering questions on an assignment, even a fairly complicated one, like the expression parsing question, these are not sufficiently large programs for this to really be an issue. But I'm not trying to teach you how to answer math problems for the rest of your lives. I'm trying to teach you how to actually functionally work in the environment that you have, which means working on large programs, and large programs take a long time to compile, so you need to know the tricks to get them to compile in a certain amount of time. Because, you know, contrary to what that one XKCD cartoon says, taking you know, half an hour to 45 minutes out of the middle of your workday every time you have to compile something is no longer considered acceptable practice. So we're going to see how we can use variables, and this is variables in the bash scripting sense, in order to increase the flexibility of the make files that we've produced so far. So, as with so many things in life, we can make things once again simpler in the long term by complicating things in the short term. Make files support variables, which are similar in many ways to the variables in shell scripting. Variables, once again, need the variable substitution operator. So the variable substitution operator in bash scripting is $sign and then parentheses. This time, enclosing the variable name in round braces is considered good etiquette rather than being strictly required. Fast compiling time is happy Mr. More time. You know it. Like, the thing about like a lot of modern languages is that they build this kind of thing directly into the IDE, right? But with development, like, in order to understand the principle of what's going on, you need to have like seen it done at this level, right? It's like this type of makefile functionality is like, for example, with my my actual thesis code, which is 10,000, or no, it's more like 20,000 lines of Haskell. Haskell has a package manager called Stack, or a project manager called Stack, which it's a command line tool, but in a lot of ways it performs a lot of the functionality that a IDE would. And one of the things it does is it only recompiles files which need to be recompiled. And let me tell you, if you perform a full compilation of those 20,000 lines of Haskell code that constitute my thesis research, I think that thing takes about 10 minutes to compile. Whereas if it's only like the top 2 files that needed to be recompiled, it takes like maybe 30 seconds to a minute or something like that, which means you can get more iterations through, which means you can work faster, which means you're more productive. So, you also don't have to worry about leaving some white space this time around, but don't go overboard. When this is set up correctly, variables let us control many things about our compilation process from a few lines at the top of the file. So, for example, we can set the compiler. So let's say, just for the sake of interest, we didn't want... Let's say we were in a situation where we wanted our project... we wanted to be able to compile the project on several different C compilers. Let's say we were doing profiling over the different C compilers that exist, and we wanted to compare how quickly the subsequent files ran, or something about that. You know, we wanted to see how these compilers worked. If we say cc at the top, gcc, this sets the variable cc to the value gcc. We can substitute in everywhere we use GCC, we can now use our variabilized compiler. Now, so this is okay. This is okay in, so far as it goes. The problem that we're going to run into, however, if you stray sufficiently far from the beaten path, is that a lot of the flags that you're going to be using in compilation are dependent on the compiler, right? I don't think it's such a big problem. Like, GCC stands for the GNU Compiler Collection, but in Linux, the default, quote-unquote, default compiler is actually CC, not GCC. So GCC is like the GNU version of CC, right? And if you, it looks like they just linked to GCC now, so that's interesting. But back in the day, these used to be different compilers, but they've since amalgamated, I guess. It's, that kind of thing is included primarily for legacy reasons. But yeah, so you can abstract out what the actual compiler you're using is using variables. You can also set some flags. So let's say I wanted to apply to all of these C flags. Let's say I wanted to get rid of the O flag, right? I could just introduce a variable that specifies the O flag. There we go. So now that I've set this up, if I wanted to make some kind of global change to the flags, all I'd have to do it is in one place at the top, which is much, much, much easier. So if I wanted to, for example, turn on all warnings, I could do that. If I wanted to set level 3 optimizations, I could set level 3 optimizations one step at the top. Oh, yeah, I should mention optimizations, actually. So one of the interesting... I think we might actually talk about optimizations here. Maybe? Maybe not, but possibly in the next one. So with optimization, using the C compiler, you can set like O1, O2, or O3. That's level 1, 2, or 3 optimizations. And these are a bunch of, just a bunch of things that a lot of people have done a lot of research over the years to increase and improve the efficiency of C/C++ code. So it would be very interesting to me. This person, I think that was this class? Might have been this class. Someone told me that they or someone they knew took a image processing library, took it from Python to C++, and got a 5 times speed improvement. It would be interesting to me to see what that speed improvement would look like if they had optimizations turned on as well. But yeah, so you can do that. The one thing about turning on optimizations, though, is that it can drastically increase the amount of compilation time, which means that, putting things into a makefile and only compiling those things which need to be recompiled becomes even more critical to your workflow. So there you go. We can also abstract out the list of objects. Also, Makefile comments use octothorpe characters, by the way. You can abstract out the list of objects, although this is like, unless you need this like multiple other places in the code, all you're really saving is like being able to use it twice, once in the set of targets and once in the actual compilation line. So this is like not as much of an optimization, but it could still be an optimization. So, although it isn't required, it is conventional to include a cleanup phony target, which deletes files during executable generation, which deletes files used during executable generation, but which are not needed afterwards. Specifying no prerequisite makes it a standalone rule. So if I were to take a look at the makefile that I wrote for my LaTeX thesis, LaTeX produces a very large number of useless files. Like if I were to take a look at the, like there are probably a bunch of them here. Yeah. So like .aux, .log, .nav, .out, like .log is just the output of the LaTeX compiler itself, which gets saved to a file for some reason. And by default, like you can set a flag for it to not do that, but it's like, who wants to go to the bother, you know? So like, you know, this file, this file, this file, this file, this file, that file, all, and this one, can all be deleted safely. You know? Because the only thing that really matters in LaTeX is this source file, right? So in C, we're only really talking about output the .o files so far, but as we're going to see, as you do other things, you might be more interested in deleting some things that you generate in the process. So, yes. So on RM, if you use the F flag, that means force. So if there's no if you ask RM to delete something and it doesn't actually exist, it'll complain. -F stops it complaining about that. So, another phony target typically included is all. This isn't necessary unless a makefile has more than one final target, i.e. if there's more than one top file that could have gone into the top slot. Basically, if you have competition for the top slot, put an all rule in. The all rule typically doesn't do anything by itself, it just queues up all valid final targets for regeneration by making them prerequisites. It sometimes also, sometimes you also put a clean routine in there. So, for example, with this guy, all constitutes build and clean. So it builds all of this, and then it also performs the clean operation. So, any questions about that? Because we're going to talk about testing. Can I get a thumbs up at least? Wow, attention is dwindling, eh? Jeez. Thank you. Cool. So, this is why we test things. Can't find a thumb emoji. That's okay. If you want, you can select the dab emoji. So there we go. So automating things is both efficient and satisfying. So let's automate one more tedious task of programming. Testing. So, when testing a program, we can compare the expected output of a program. It seems a little behind in the stream. Yeah, maybe it seems our latency is pretty pretty bad today. But yeah. What are you going to do? So, when testing a program, we compare the expected output to the actual output. Of course, this only works if both outputs were produced from the same input. The expected output can be generated by a number of processes. So, either you can have a human decide what the test case should be, you could have a different, perhaps less efficient algorithm, which you know is correct, produce the output, right? Or you can base the output on customer requirements. This case, you might think that this case doesn't come up a lot, but you'd be surprised by how many times this comes up. It's like you have an older or slower algorithm that does something, you want to reproduce that functionality, you can use the old program to generate test cases for the new one. So, let's talk about diff. Let me just take a look and see if I've got these diff files in here. Not so much, eh? So we can easily produce a couple of examples. So, but let me explain how it works first. So, we're introducing what's called the diff command. So let's imagine we had two text files, right? We take a look through these, and we notice, this one's got special node equals 4, this one's got special node equals 5. Right? By calling diff, you get a report of all of the differences between two files. Right? So, for example, if I took a, let's take two things that, let's get it text1.txt, text2.txt, right? Let's make text1 ASDF. There we go. Let's make this one. And let's just make the small difference between these two files. Save that up. Save that up. Diff text1.txt, text2.txt. You can see it tells you the line, it tells you where the line is, first of all. So it's on line 2 in both files. Text1.txt has this version. The other one has that version. So it sort of gives you a left-right report on what the differences between the two files are, right? And you may be saying to yourself, okay, sure. How is this relevant to testing? So this is how this is relevant to testing. You run the program, you generate an output file, like an output report. You then compare that using diff to an output report that contains the correct answers. That will tell you whether or not everything worked. So, up to now, we've been comparing our expected and actual outputs manually. This is, however, slow, tedious, and a bad use of human resources. The diff command automatically reports the differences between two files. Combined with output capture and bash, we can run a program, collect its output, and compare it to a pre-existing file that gives us our expected output. Does C2 mean character at index 2? Ooh, maybe. I don't think so. I think that's line, like C means, like, it's both on line 4, you know? Because, like, in this example, the difference is, like, the last character on the line. But I think it's, like, left 4, right 4. because it's like on the left this is line 4 that's different, on the right it's line 4 that's different. So it's probably like taking spaces into account. Let me just see here for a second. Let's see if diff can handle that. Yeah, there you go. So not only does it tell the difference between like single lines, it can also tell when lines have been inserted. So there you go. Does diff work with C files too, or just text files? Nah, it works with anything, dude. Chaw. Yeah, literally any plain text file format, you can use diff. So diff sums.c products.c. There you go. Just like that. So let's talk about output capture. All right. So let's imagine we had, well, actually we have top, don't we? Oh, that's not what I meant. Yikes. That's like htop, but less h. All right. So, why does top have an asterisk? I'm just going to recompile it. Oh. Crap. God damn it. Alright. Now I gotta fix it. So what happened was, like, they fooled me. They have an asterisk on the end there, but I forgot temporarily that that's a glob pattern that also catches the top.c source file. This might actually be interesting to you to see how I recover from this. I always have to look up the command, though. Okay. There we go, and now it's back. So, so that's a nice little lesson, actually. So what happened there was, because the command line environment can be a little bit tricky, I had accidentally deleted the top.c source file, which I needed, of course, to, you know, regenerate this guy, which I will now do. Because in an overabundance of caution, I store all of my course materials for the courses I teach as private repositories on GitHub, because it's very useful to be able to have an archival system with respect to these things. It also vastly improves my ability to share the course materials with the TAs. Like this, it's very mildly like Google Drive, but so much better than Google Drive that you can't even compare the two of them. They're like in different leagues. But anyway, so I had accidentally deleted this file, so I was able to ask my Git repository to just go to the most recent commit that I made, right? You guys did Git at the beginning of the semester. That just goes back to the most recent commit that I made and pulls that version of the file into the current directory. So I was able to restore it. There we go. So that's why you do this kind of stuff. Because RM cannot be recovered from except by means of stuff like that. There's no recycling bin. So, if I want to capture the output of top, the top executable, I can use the sort of angle bracket. It looks like greater than, but it's more like stream it this way. It's supposed to like be symbolic. This isn't greater than, less than. So, if I run top, you'll notice that it's not actually outputting anything. Essentially what I'm doing is I'm taking the information that was going to be written into standard output, and I'm capturing it and storing it in a file. So if I actually take a look and get it output.txt, it probably have to wait till the program is over with before. I thought it would be cool you could see it like updating, but apparently not. Apparently that's too fancy. So I'm just gonna cut this off. There we go. Let's cat output.txt, see what we get. Nothing, come on. Maybe I need to like F-flush inside that file. Well, let's perform a minor modif. Oh, its class is over. Gosh darn it, just when I was getting warmed up. Let's just comment this guy out, so that it'll just be these two print statements. I'm almost finished. Almost finished. Remake. There we go. Capture output. There we go. Cat output. There we go. Ta-da! It didn't flush the buffer. So, like if you run top without the output capture, it just prints it to standard output. But if you do it with the output capture, then it just writes that to a file. And because it writes it to a file, that file can be used for diff. So let's say, well, anyway, class is over. Sorry. We'll, if there are any questions, ask me the questions. Otherwise, I will continue this very enthusiastic discussion next time. But in case you're wondering, this is how the actual, like, C workflow works. Can I ask a question about the last assignment? Just curious about one thing. Yeah, hit me. I'll pull it up. As long as your question isn't, why do I have to do it? I mean, you can ask that question, but you probably won't like the answer. Because the answer is because I said so. On the Piazza forum, I actually got a student in my third-year class who said something like, "Why should I have to do this?" It's like, because I told you to, and I'm the professor. For assignment 4, last Q. What? Do you know if any test cases include redundant operators? Oh, the last assignment. Oh, like the one that had just happened. Oh, okay. Alright, yeah. The previous assignment. Assignment 4, yes. Do you know if any of the test cases include redundant operators or numbers like adding by 0 at the end? So I can tell you that there are no redundant operators. So it will always be of the form literal operator literal, literal operator, literal operator, literal, you know? Like, you will always have operators sandwiched in between the literals. Absolutely. Adding 0 at the end, however, that is perfectly valid. So that's a valid case. So something like, 5 minus 8 plus 0, there's no reason that wouldn't be a valid case. But with respect to redundant operator, like, I guess I don't really know what you mean by redundant operators. Like, like multiplication at the front or something with nothing. Yeah, no, like this is not a validly formed. That's not a valid expression. Like plus and then no number. No, why would I do that to you? Why would I do that? Like, just like that? No, why would I do that to you? That would be cruel. No, you can assume that all of the expressions that you're going to be tested on are syntactically valid expressions according to the rules given. Aside from the fact that the question itself is quite difficult, there are no gotchas in it. Like, there are no gotchas in the test cases. The question is hard enough without needing any gotchas. And I don't like gotchas in test cases anyways. Except when it's like something legitimate. Like, testing to make sure that your thing still works if it's an empty list in like Haskell or Python or something like that, Like, testing edge cases is not the same thing as gotchas, but like that, the cases you're describing would actually like violate the rules as given, but yeah, for some reason yours didn't work if plus 0 was at the end, but it's whatever now. I was just working. Oh, I think I know what that probably was. I think, yeah, I could probably tell you why that was happening. If you were using the null character to terminate a string, that is 0, right? The integer interpretation of that is 0. So if you were using null termination somewhere on an array of integers, 0 would count as being a nothing, right? So it would not register. Like, if you set up the array so that, like, 0 was, like, a blank, then if you had a 0 at the end of it, it would count as blank rather than counting as 0, which is what it was supposed to do. But, yeah. But yeah, it's interesting. I love the question because it presses on all of those interesting little edge cases. Like, if you managed to accomplish this question, you should be proud of yourself because this was a difficult question. But, yeah. Anyway, are there any other questions? Even if the 0 is a char. No, if the 0 is a char, you're okay. But if you took the 0 as a char, converted it to a 0 that was an integer, and then put that somewhere that was expecting null termination, then I could see that describing the bug that was just described. Aww. I think I may have broken the record for longest question 3 answer. Oh yeah, how long was yours? How many lines of code? I will check to see how long my solution is off screen. So, all told, including the main function and all of the testing, everything, it's 145. 145 lines of code. Can't say that and not include the number of lines. Yeah. Yeah. That's a lot, man. That's a lot. Yeah, it's also, like, kind of true of programming code that, like, the more of it there is, the harder it is to debug, you know? Like, every line of code, you have to look at every line of code you enter as being a potential entry point into your program for errors. Someone did theirs at around 30 lines. What? Come on. Come on. If true, that makes me suspicious. It's like, what did they do? Just, like, invoke a exterior Python script that called eval or something? Because if so, no marks for that, I'm afraid. I went for ultimate redundancy just to make sure it worked first try. Yeah, did it? Because to get something like that working first try, that's, that would be pretty impressive. I could probably have gotten mine down to, like, 150 if I deleted some of the redundant stuff. Yeah. Ah! I think 175 is perfectly acceptable. Yeah. Yeah, and besides, we're certainly not marking number of lines of code, right? It's kind of interesting, because, like, that means for you, Commander, that, it took you, like, 9 times as long to write that question as it took Ethan, probably. You know? Maybe not. Maybe Ethan thought about those 150 lines of code, maybe Ethan thought about that for longer, you know, per line of code, but yeah, you know? Yeah. Anyway, I think that's it for me for today. Take her easy, folks, and we'll see you in the next one.